Hi there and welcome to this video for Senior Physics on Light and Waves. This video we're going to look at some simulations with respect to wave interference, especially with respect to water waves. So what we're going to use for this simulation is the website that you can see at the top here, PhET Colorado. This is a really good website which really allows you to start playing with a lot of ideas with respect to waves, sound and light. And we'll be using this site a number of times during this course. I have put the link for this site on iTunes U, so you can download it and do have a good play with it. It's really a useful tool. But what I'm going to do is try and take you through the first portion of this wave interference module. So what we're going to look at in this unit is wave reflection when it hits a straight barrier. So for example, what happens when a wave hits a harbour wall, for example? Straight harbour wall, waves are coming in, what's going to occur? We're also going to look at what happens as waves pass through a gap, and then we're going to look at what happens as waves move around a barrier. And we'll try and explain as close as we can with respect to everyday occurrences. So let's load up the site. Okay, so I'm just going to load up the site here. Go. You get this site that comes up. Now, you can use this site many times to do a variety of different things. So go on and have a good explore because it really is quite good. So we'll run now. We'll just download that. I'll open it up. Now, you don't have to subscribe to this. It's a free online process that you can use. We're going to run it. Here we go. Alright, so basically what we get, I'm just going to enlarge the page there for you. And we'll just enlarge that a wee bit more. Excellent. So what I've got here is just a tap. Now, the tap here basically is demonstrating the water coming in. And what you'll see is our wave. Now, you can see it's of a specific wavelength. Now what we're going to be looking at, when you deal with a wave, we have things called wave fronts. Now a wave front can be virtually anything, but generally we tend to say a wave front is going to be a crest. Now down here on the left-hand side, I can increase my frequency just by moving the blob along. And you can see I now generate faster frequency with a smaller wavelength. I can also increase the amplitude of the wave. And if I look at my graph, just minimize that there. You can see the wave which is being generated with the amplitude. Obviously, the more I put it up, the bigger the wave, and as I pull it down, the smaller the wave. So you get a rough idea as to how it works. I'm going to work with a wave around about half speed, and I'm going to work with a frequency approximately 3/4. Okay, so the first thing that we're going to do is we're going to see what happens when we add a straight barrier, and we'll have a look at and see what the effects are. You can see I've got some nice, decent wave fronts coming. If we look at the idea of the dark areas being the wave fronts, then you'll get an idea as to what happens. So I come down to the bottom here, and I'm going to add the wall, where it says down here, right-hand side, add wall. I place it in like so, and I can rearrange my wall to wherever I want it to be. So let's just push that in. I'm going to pull that across, so it's about 3/4 of the way in. Now what you're seeing now is the wave is coming along. You've got the incident wave coming from the tap, coming in this direction here, and then as it hits the barrier, it then reflects off. Now what you're seeing here is a standing wave which is being generated from the incident wave coming in compared to the reflected wave coming back. If I just remove that again so we can see our pattern, I'll just remove it again. There's our normal pattern. You see we get that nice steady stream of wavelengths, and then as soon as I add my wall, the result is we then start generating these waves which reflect back. And what I get in the middle is this standing wave, and we've got this oscillation between up and down. If I look at my graph level, we can see that standing wave which is being generated. Now notice what's happening here, that as the wave comes in, it's oscillating up and down, up and down, up and down. This is due to the reflection coming back off the surface of the barrier. So it backs up what we talked about earlier when we were looking at the standing wave unit. Okay, so that's good. So we've got our wall, and obviously we can move our wall wherever we want. So let's put it now, instead of having it straight on, let's put it at an angle. We'll put it at an angle there. And what's happening now is the water waves are going to come along, and you can start seeing this interference. Now this pattern here is, as the wave comes in this direction, it is going to bounce off, and the law of reflection applies. What that means is that if I was to draw a normal line through this point here, the angle at which the incident wave comes in is the angle that it comes off. So the angle of incidence to the normal on this boundary is the same as the angle of reflection coming off here. So you can see our wave is coming here. We've got a bit of a standing wave here, and what we've got here is then a reflection coming off, and it's going to be interacting, and we'll talk about that interaction later on. So we've now seen what happens with a barrier when it's straight. We've seen that the barrier, when it's at an angle, we've got the angle of incidence equals the angle of reflection. So let's just remove this now and go back to our normal wave pattern. So what I'm now going to do is add a gap. I'm going to add a slit, a bit like a harbour wall with a hole going through it where the boats can come through. The result is that the waves are going to pass through. Also, you could think about it with respect to whitewater rafting, and the idea that as you go through some boulders, you're going to generate some form of wave which is going to occur. So the wave's going to be moving through the boulders. So I'll come over here on the right hand side, and I'll go to that one slit area. And I'm going to move my slit to about 2.5 centimeters apart. So I'm going to move my barrier, and I'm going to put it around about that position. Now what we tend to see when we look at the splits is, as the wave moves through, the wave front passes through, and then what tends to happen is it catches on the edges here. Now as it catches on the edges, the wave is actually going to slow down. Now as it slows down due to friction, the middle part of the wave is going to continue at its normal speed, and it causes this effect to curve the lines on the edges. So what we get here is this sort of funnel shape of the wave as it actually moves through the gap. In these areas here and up the top here, what we notice is that we've got a shadow. Okay, we've got an area of very, very still water because the waves are not able to penetrate. So as it passes through, we get this undulation, and what we'll get is some reflection here, we'll get some reflection here, and we'll have a form of standing wave right in the middle here, which may increase the amplitude of the wave. And if you ever watch water flowing through a gap or between two boulders, you'll see this big wave right in the middle forming. Now, we will notice that as we increase the speed through the wave, the barrier itself has less of an effect. Okay, so there we are, we go it through, we've got our speed increasing. You'll see that we get less of an effect here and less of an effect here. We've still got our shadows, but where it curved round all the way, we've got less of it. Now we can also see this more if I decrease the width of the slit or the gap, and you can see that we're getting more of a beam which is generated here and here rather than this curving. We'll get some very gentle ripples which are generated here, but really the beam is coming through in this area. Obviously, as I increase the slit, there is less of an effect, and we get a straighter curve which is generated, because what we're finding here is that there is less water which is affected by the ripples generated by the gap. Now this is really, really interesting, and if you try and think about it, back in the, I think it was the Beijing Olympics, they made, for whitewater kayaking, they made their own river using boulders, and by changing the position of the boulders, they could, and the flow rate of the water, they could actually produce some really, really cool waves and slalom rapids which the kayakers had to navigate. So This is just really giving you an aspect where physics could actually be utilised on the sporting field with respect to kayaking and looking at the waters by changing the boulders and the speed at which the water flows over certain areas. What we can then do is find that we get different undulations of water, and it's obviously a lot harder to deal with. So that's what happens when we deal with a gap. If we increase the frequency and narrow the gap, we're going to get more of a pulse. If we decrease the frequency and open the gap, we're going to get a flatter curve, which is going to generate because the waves actually are not really affected as much. Okay, so let's remove our slit, and the last one we're going to look at now is what happens if we put a barrier in. So I'm going to put a wall, generate a wall, or like a large boulder which is in the path of my wave. I'll put it in the middle there. Now you'll see that we generate a standing wave from reflection. This is simply because it's a flat surface, so it's acting like a mirror. But what you'll notice is as the waves come around the edges here and here, you'll notice that they begin to slow down due to friction. These waves are moving quickly, but around the edges you can see this curving. This curving, as I say, is due to slowing of the wave. In the middle, just at this point here, you can see that there's an area of shadow. It's very, very calm, and the result is that's because the waves cannot penetrate. Eventually, the waves will meet in this area here and just carry on their journey. Now, obviously, if I decrease the frequency, we'll see there's less of an effect, and the shadow actually increases because it takes a lot longer for the wave fronts to actually meet up. So I get this nice shadow area with respect to my barrier. So the barrier basically will produce a shadow behind it. We get this curving due to this slowing down of the wave as it hits the barrier. Anything which is further away from the barrier will remain at its constant speed. So it'll actually be moving faster, so we get this curvature. Okay, well I hope you found that useful. We will be using this simulation again, so do have a play, go on and see what happens. And I look forward to seeing you again when we will look in a little bit more detail at our wave interference. Okay, so thanks for watching, and I'll meet you again soon.